Today we are going to solve LeetCode problem number 222, count complete tree nodes. We are given root of a complete binary tree and we have to return the number of nodes in the tree. The first example here has a tree of total 6 nodes, 1, 2, 3, 4, 5, 6, and we have to return 6. In the second example, if the root is empty or null, we have to return 0. And in the third example, if the root only has a single value or a single node, we have to return 1. The root here has a single node, so we are returning 1. Here root is empty, so we have to return 0. And here root has total of 6 nodes, the tree has total of 6 nodes, then we have to return 6 here. Let's discuss the code snippet here. It is a class with name solution with a public method called count nodes defined in it, and it is of integer type. So we have to return an integer value, the count of the nodes, and the parameter here is given the root of the tree. So for questions related to trees, we mostly use recursion. So for this question too, we are going to solve it using recursion. Okay. So first of all, we will draw a tree. Then the code of this problem is really simple. We will first write the edge case if not root, then return 0. If we remember correctly, this was also our second test case. So for solving the recursion problems, we divide our main problem into smaller problems. So here, instead of taking this big tree, I'll take a smaller one. So what we basically want here is count of the left children 1, count of the right children 1, and count of the root 1. So I want it such that it gives me count of the left children, count of the right children, and I'll add one for the root myself. So we will write here return 1 for the root node plus we will, let's say our function is count nodes with a tree node pointer root. Okay, so we will pass our left children and then call it again to pass our right children. Let's say count nodes right. So here if we dry run it, we have this as our root node. So we will add one of this node and then we will pass our left children. We are passing our left children in the count node again. So basically now the argument here is the left node. The tree node is not the root but root's left. So we will add one again. Now this is the root. So we will add one for root again and then we will pass its left children. So here we are adding one for this since this is the root now and this root doesn't have any children. It's null. So we will meet our base case which is to return 0. Then we are again on this function because we passed our left children. Now we will pass our right children. We pass our right children. So this is the root now. It will add 1. This also doesn't have any children. So here also it will return 0. And finally this root will have 1 from here, 1 from here, and then it will pass its own one to this. So basically we are getting 3. 1, 2, 3 in this node. And now we will pass our right children. Now this is the root node. We will add one of this. It has a left children. Now this is the root node. Again we will add one. This doesn't have any children, -1, so it will return 0. So from here we are getting 1, and from here we are getting 2, one from this and one from its child. So from the left side we are getting 3, from the right side we are getting 2, and adding one of its own, the roots count, we are getting finally 3 plus 2, let's say 1 plus 3 plus 2, 1 for the root, count left 3 nodes and 2 for the right node. Okay, so now let's quickly solve our problem. We have to define the base case here, f not root, then return 0, finally return 1 for the count of root. Then we will pass our left children in this function again, root left. Then we will count the right nodes or right children. So roots right. So the test case, all 18, it is submitted. The time complexity here, if we analyze it, it's order of n, because we are traversing through n nodes, and also since we are using recursion, it always has a space complexity of its stack. So space complexity is also order of n.